All right, in this section, we're going to talk about abstract classes. And abstract classes tend to be one of those subjects that trip people up who are learning object-oriented programming for the first time, so I'll try to make this easy. Essentially, an abstract class can't be instantiated by itself. You have to create a subclass, and you have to instantiate that instead. In other words, you've got to derive a class from an abstract class and make that class instead. You can't instantiate an abstract class. Abstract classes have abstract members, and these are members that have to be overridden by subclasses in order to provide functionality. So, okay, why would you do this? Well, there are going to be times in programming where you define a class that describes an abstract idea but doesn't make sense by itself. It has to have an actual physical implementation, and that physical implementation is going to change among different versions of that class. And we'll take a closer look at that in a moment. First, let's see how to actually describe an abstract class. Abstract classes are indicated by putting the word abstract in the class definition. So if I normally describe a class like this using public class, my class, and then declare the class normally like you've seen me do throughout the course, what I would do here instead is put the word abstract inside the class definition. That tells the compiler that this is an abstract class. Then once I've done that, I can declare an abstract member function like you see here. Now, I don't provide an implementation for this function here. Remember, I'm forcing the subclass to do that. The subclass has to provide an implementation. So let's take a look at a real-world scenario where you would do something with abstract classes. Consider an example where you've got a car dealership or some kind of dealership where you sell different types of vehicles. Now, vehicles, depending on what they are, have unique characteristics, but some of them might be common among all different kinds of vehicles. For example, they might have properties like what kind of fuel that they use and what their licensing code number is, right? But you don't actually go down to the dealership to buy a vehicle. What you do is you buy something like a motorcycle or a car or a truck or a boat. These are real-world implementations of this abstract notion of a vehicle. Even though they may all share some of the same characteristics, there's no such thing as actually making a vehicle. So in this case, if the vehicle, the class you see in the dotted line there, is an abstract class, and the classes you see in the thick lines are real subclasses that derive from the vehicle subclass, you could do something like this. I could say class car C equals new car. That works great. It's a real class that derives from the abstract class. What I can't do is this. I can't actually instantiate the abstract class because the rules of object-oriented programming in C# is that abstract classes have to be derived from. So I would have to instantiate one of the real classes, the motorcycle, the car, the truck, the boat, and I could add more real classes as time goes on. So let's just go over to the code and see this in action. Okay, I've got my abstract classes example opened. Let's go over to the snippets. You can see I've scrolled down to my abstract classes and methods section. And I'm just going to copy these two class definitions, and I'm going to paste them in my program over here. So now I have my abstract class, which is my base class. And in there, you see I've got my abstract method called myMethod. And then if we scroll down a little bit, you'll see here, starting on line 13, I have a derived class, which inherits from my base class. And it overrides, again, I'm using the word override here, to override the abstract member function called myMethod. And in this case, it just takes two arguments and returns the sum of those two arguments. So if we go down into the main function, I could do something like this. I can say my derived class equals new my derived class. And then I can say int result equals, actually I have to make a variable there. I can say mdc dot, and then I can call my method right here. And I'll just give it two numbers, 5 and 6. And then we'll just write out the result there. And then we'll have the program wait for us so we can see the results. So let's save this and let's run it. And you can see that the results here is 11. Why? Because 5 plus 6 equals 11. So we can see that the real derived class from the abstract class provides an implementation and actually works. Let's comment this code out so we don't have to deal with any errors in it. Okay. Let's see what happens when we take the myMethod implementation out of the derived class. I'm just going to cut this code and save it. And now I'm going to hit F6 to build. And you can see that we get an error. There's a little blue squiggle underneath my derived class. And if you look down here in the error list, it says abstractclasses.myDerivedClass does not implement inherited abstract member my method. So you can see that because I declared my method to be an abstract method, I have to override it in my base class. So let's undo that, put that back in, and the error goes away. Let's try another little experiment. Let's do this. Let's say my base class MBC equals new my base class. And we'll save and we'll build. Oh, another error. What's the error this time? It says, cannot create an instance of the abstract class or interface my base class. Abstract classes, as you can see, cannot be instantiated by themselves, and this is enforced by the C# compiler. So let's go ahead and delete that code. So abstract classes are a way of defining abstract ideas that group together some common properties and functionality of real instances of that class, but it's just abstract. You can't actually instantiate that class. And it's a way for you to write your programs such that you can group together the related pieces of functionality, but force people who want to use your classes to override them and make real physical instances of them.